Welcome to your IELTS listening practice from Spinta.org. This is a mini-test designed to help you practice a specific section of the exam and improve your confidence. The recording will be played one time only, just like in the official test. Let's begin.
Welcome to today's examination of ocean acidification, often called the other CO2 problem alongside climate change. While global warming captures most public attention regarding carbon dioxide emissions, the ocean's absorption of atmospheric CO2 is creating a parallel crisis that threatens marine ecosystems and the billions of people who depend on ocean resources for food and livelihoods. The chemistry of ocean acidification is straightforward but profound. When carbon dioxide dissolves in seawater, it forms carbonic acid, which releases hydrogen ions and lowers the ocean's pH. Since the Industrial Revolution, oceans have absorbed approximately 30% of human-produced CO2, causing a 0.1 unit decrease in pH, representing a 30% increase in acidity due to the logarithmic nature of the pH scale. This chemical change fundamentally affects calcium carbonate formation, the process many marine organisms use to build shells, skeletons, and protective structures. As seawater becomes more acidic, it becomes more difficult for creatures like corals, mollusks, and some plankton to extract the carbonate ions they need for calcification. Existing calcium carbonate structures may even begin to dissolve. Coral reefs face particular vulnerability to acidification. These ecosystems, which support approximately 25% of marine species despite covering less than 1% of ocean area, rely on calcium carbonate to build their skeletal structures. Laboratory studies show that under projected acidification levels, coral growth rates could decrease by 15 to 85%, potentially leading to reef degradation, even without considering temperature-related bleaching. The impact extends to microscopic marine life that forms the base of ocean food webs. Pteropods, small sea snails that many fish species depend on for food, show shell dissolution in areas where acidification is already occurring. Similarly, some phytoplankton species that produce oxygen and sequester carbon may be affected, potentially disrupting global ocean productivity. Regional variations in acidification create hotspots where impacts are already observable. The Arctic Ocean is acidifying faster than global averages due to cold water's increased CO2 solubility and melting ice that dilutes buffering compounds. Coastal upwelling zones where deep, naturally acidic water reaches the surface are experiencing conditions not expected globally for decades. Economic implications of ocean acidification could be substantial, particularly for shellfish industries. Oyster farmers in the Pacific Northwest have already experienced production failures linked to acidified water, requiring expensive buffering systems to maintain viable growing conditions. The global shellfish industry, worth billions annually, faces potential widespread disruption as acidification intensifies. Unlike climate change, ocean acidification cannot be reversed quickly, even if CO2 emissions stopped immediately. The ocean's natural buffering capacity has been overwhelmed, and restoring normal pH levels would require centuries to millennia of natural processes. This irreversibility on human timescales makes prevention through emission reduction the only viable solution. Research into adaptation strategies includes selective breeding of resistant species, assisted evolution to accelerate natural adaptation, and local interventions like alkalinity enhancement. However, these approaches are expensive, technically challenging, and cannot address the scale of the global ocean. They may provide temporary relief for specific valuable ecosystems, but cannot substitute for addressing root causes. Ocean acidification exemplifies how human activities can trigger cascading environmental changes with far-reaching consequences. As we continue to pump CO2 into the atmosphere, we're conducting an unprecedented global experiment on ocean chemistry. The results will determine not only the fate of marine ecosystems, but also the food security and economic stability of coastal communities worldwide.
You have now completed the practice test. When you are ready for a full exam experience, visit us at Spinta.org. There you will find complete mock tests for all 4 skills: listening, reading, writing, and speaking. Our platform provides instant AI feedback for your speaking and writing tasks, along with an accurate prediction of your band score. Take control of your preparation at Spinta.org.